Hello, good day to you all. I am Martin Kagan, founder, creator, and visionary for this spatial database engine renditioning. Before your eyes is able to produce an array of visual images that are unlike any others seen prior. We've applied this to climate change, and this is another in that series. This may well be a defining calculation in that said field. Previously, we have already looked at what the system looks like relative to a particular year and the delta changes within that year over a said sequence of latitude. So latitude in this particular case is from top down, and timing is through on a clockwise or anti-clockwise dimension. Changes here are reflected inwardly and outwardly at the node level at delta. The delta gives us the ability to see the data at its core. You can obviously see that there are negative reductions in carbon CO2 emissions, which is a good thing. However, these occur infrequently relative to the volume of carbon emission or CO2 emission throughout the northern hemisphere. This is from the equator upwards. This can also be seen in a grid format where we have a heat map concept of high and low. Below the surface is good, reduction in carbon. Above the surface is increased carbon, CO2 production over the latitude structure. That structure ties up implicitly with the data set supplied to us through the services of NOAA. The data set itself is fairly extensive, and we want to make sure that everybody's aware that this is multiple hundreds of lines through the years by latitude. As can be seen, the numbers are consistent, but they are a very large array, and definition in that array has been challenging, to say the very least. What I have seen relative to this is the following renditions of data. I'll be very quick. Here is the carbon footprint on the global scale. It is inverted, unfortunately. Dark means good, light means bad. It's just how they calibrated it. So we won't have the same error. Also, the summary of the totality as supplied through NOAA through the Mauna Loa data set is extensive, and it represents this change in the CO2 levels over a long gestational period and over the entire latitude structure of the Earth. The latitude structure of the Earth being such. The reason I'm doing this is I've taken this and I've structured the latitudes into 4 quadrants. So you have minus, positive 90, and negative 90. We can associate with that. And then we have increments of approximately 45, so that we have, in essence, 4 quadrants in terms of latitude that we're going to be looking at. So without wasting further time, let us look at what this data looks like once we invert it, and I'll make sure that you understand what I'm talking about. Here we had latitude on the top horizontal line, which is traditionally time, and time on the vertical. I flipped the chart and I created an index. So time is now, in terms of the pivot, time is at the top, latitude goes down, latitude is subtotaled, as you can see, from 1 through sections 4, as I indicated in the previous description. And we look at this data now based on delta. You can see the data is sub-zero, which means it's minuscule, and to be able to see that change is significant. These sub-zero amounts, once accumulated, amount to significant effects on the Earth's CO2 generation and or its reduction. And that's what we're going to be studying right now. So from that version, we now switch dramatically. Time is on the top line, which is the traditional way that we have always shown time in the system. And as you can see, I'm showing you the elements that I have created relative to the substructure. I've set it on the left-hand side to cumulative. On the right-hand side, it's not set to cumulative, it's set to the delta value. All are set to root, color is set to name. We switch off all those factors so that we just observe at this point in time, and the observation is critical. We can see there are continuous delta changes. The structure of the data is that the bottom two quadrants, the bottom two sections over here, are 1980 and 1981. I have then added to that, just like you graphed onto a tree, I've grafted onto that time periods 2016, 17, and 18 to see the changes thereon. This is set to autographic mode. For those of you that understand and know the difference, it is critical in the assessment of data in three-dimensional format. It is clear that there is seismic changes each year, clearly visible. So there is a reduction. I presume a reduction in carbon emission is going to tie in perfectly with the summer period in that area of the world. And then the carbon footprint increases, the CO2 footprint increases accordingly. To see this in the full extent, we now look at the totality of the Earth, not by sector, but in total. And here we have those four quadrants that we described. And we are going to focus on these two specifically, because they have the largest variation of delta cumulative, and they are specifically the top section, the top 90, and then the middle section above the equator. For that, we choose, since it's numbered that way, we will choose, let's say, this item over here. Come back one step. And we are where we looked at just a few moments prior to this data set. This data set has been further refined, and same data, except here we see it from the index structure basis. Now, with that said, we are keenly looking, as we said, at these two sections, left and right. And we have to step back one. That's the changes in delta. And these are the consistent 2, 4, 6, 8, 10 sectors consistently for each of the four quadrants. And when we observe them, on the left-hand side cumulative, on the right-hand side purely delta in time, we can clearly see, without distortion, the facts of the situation. In the early years, which amounts to 1980 and 81, the first two curvature points, are far lower than the extended positions consistently applied throughout the latter years. 2016 clearly stands out, and 17. This is the 16, this is 17, and this is the start of 8 of the 18. There's the summer period and there's the winter period starting up here. That is how I am interpreting the timing of this specific data, which would coincide with the blooming of flora and fauna within the Earth's surface, in terms of the reduction of carbon emissions, and the increased CO2 would be asynchronously linked to reduction in foliage, number one, and secondly, the increase in CO2 levels during the colder periods of the Earth's summer-winter season. And since we are looking at the northern hemisphere, we are not mixing up south with north, we are purely looking at north and the effects there too. I believe that this provides sufficient and clear evidence on the quality of the data rendered and being able to correctly assess it and analyze it, that there is an ever-increasing amount of CO2 being generated annually. And this can be seen and now quantified in sectors throughout the Earth, probably for the first time correctly analyzed. It's my pleasure to have shown this data to you. Before Your Eyes stands ready to assist climate change and those believing and supporting the cause for such change. We are happy to assist further. I'm Martin Kagan, and I was delighted to present this to you. Thank you.